This is the part 2 of vitamins and hormones. In this part, we are going to see structure and synthesis of vitamin A. So, vitamin A, known as retinol, it is also known as xeroputhol. Vitamin A is called now vitamin A1 since a second compound known as A2 has been discovered. And this retinol, this nol oil at the end indicate that it is alcohol. It occurs in free condition as well as in the form of esters in fats, fish livers, and in blood. It was first isolated by McCullen 1912 as viscous yellow oil, but was further later on in 1940 it was found or obtained in crystalline form and its melting point is found to be 63 to 64 degrees Celsius by Baxter and others. It is estimated by the blue color reaction it gives with solution of antimony chloride in the chloroform. And this reaction is Carr-Price reaction. This is the structure of vitamin A1. So one six membered ring, one double bond in that ring, and three CH3C or methyl groups are at the ring, on the ring. So one, two, and three. And then one, two, three, four, five, six, seven, 8, and 9. 9 carbon chain is there. At the end, primary alcohol group is there. And in this side chain, conjugation is there. That means double, single, double, single, double, single situation. Conjugation is there. And at 3 and 7 position from the ring, at 3 position and at 7 position there are two methyl groups. That means on the ring 3 methyl and on the side chain 2 methyl groups are there. This is the structure of vitamin A1. So for the determination of structure, the vitamin, any structure when we determine, it has two parts. One part is analytical evidences in which we carry out a sort of analysis and we gather some information about the that unknown molecule or new molecule. And the second part is synthetic evidences. Whatever the information we got in the first part, that is analytical evidences, assuming the final structure of the target molecule, we try to synthesize that molecule in the laboratory. And if we got the expected results, then whatever we have assumed the structure that was correct, and we finalize or we conclude with the same. So the same scientific procedure is followed in case of vitamin A1. So first part is analytical evidences. So there are some points in the analytical evidences. First point is the molecular formula is found to be C20. The molecular formula is found to be C20H30O. It forms an ester. So first step is molecular formula. It can be found by elemental analysis, mass spectroscopy, different techniques. Second point is it forms an ester with para-nitrobenzoic acid, thus showing the presence of OH group. Any COOH reacts with OH, it forms COO ester. So, but that it contain OH group. So, when para-nitrobenzoic acid reacts with vitamin A1, it forms ester. This ester of vitamin A1, it shows that there is OH group. Then third point, on oxidation with manganese dioxide or hydrogen peroxide, it gives an aldehyde. This is very important. On oxidation, it gives aldehyde known as retinal. This proves that the OH group must be primary alcoholic group. If it has been secondary, then we might have got the ketone instead of aldehyde. But we obtained aldehyde that indicate the OH present in the vitamin A1, it must be primary alcohol. So vitamin A1 on oxidation gives retinal. This indicate the OH is primary. Then fourth point on catalytic hydrogenation, that means on reduction, 5 molecules of hydrogen are added to A1 to produce perhydro vitamin A1, that is fully reduced vitamin A1. So 5H2 molecules are consumed. That means this reaction shows that there are 5 double bonds. These double bonds are found to be conjugated because the compound gave an adduct with 2 molecules of malic anhydride. And this information is further confirmed by ultraviolet spectrum, whether those compounds are in conjugation. Conjugation means double, single, double situation. So, like this, 5 double bonds are there. Fifth point on saturation, vitamin A1 C20H30O gave perhydrovitamin A1 C20H40O on saturation. That means on removing all double bonds or on reduction, on addition of hydrogen, we get the compound perhydrovitamin A1 and its molecular formula is found to be C20H40O. If vitamin A1 were an open chain compound, then the corresponding saturated derivative should have the formula C20H42O. That means this should be the formula C20H42O, because if it has been open chain, then the formula must be CnH2n plus 2. This plus 2 is missing here. It now contains 2 hydrogen atom less. Only C20H40O. This is the compound we obtained by reduction. This shows that the molecule of vitamin A1 must contain one ring. That means two hydrogen less means either one double bond or one ring. Then sixth point, nature of this ring system. This has been determined by the oxidative degradation of vitamin A1. On ozonolysis, vitamin A1 produce one molecule of geronic acid. One molecule per molecule of vitamin A1. A molecule of beta ion also produce a molecule of geronic acid on ozonolysis. This means that vitamin A1 must contain one beta iodine ring which gives rise to geronic acid. One molecule of A1 contain one ring of geronic acid. As one molecule of A1, vitamin A1 gives geronic acid. One molecule of geronic acid. And this geronic acid and beta ion compounds, their structure is already known. So we can have the idea of the structure of vitamin A. Seventh point is nature of the side chain. The ring system beta ion unit accounts for 9 carbon atoms and 1 double bond. So here this is geronic acid and it has been obtained from beta ion ring. It accounts for how many carbon atoms? One, 2, 3, 4, 5, 6, 7, 8, 9, and 10. But when this geronic acid is obtained, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 carbon atoms and one double bond. So this is one double bond. The side chain therefore must contain 11 carbon atoms and 4 double bonds. Out of the 11 carbon atoms, one carbon atom is in the form of CH2OH. 11. Out of 11, one is CH2 in the form of CH2OH, that is primary alcohol. Oxidation of vitamin A1 with alkaline KMnO4 at high temperature give 2 molecule of acetic acid per molecule of vitamin A1. That means one molecular vitamin A1 when subjected to alkaline KMnO4 oxidation, then we get two molecules of acetic acid. This reaction shows that there are two double bond CCH3 units groups. These two groups are there. If one group is present, then we might got one molecule of acetic acid. But we obtained two molecules of acetic acid per molecule of vitamin A1. This indicates that there are two such units in one molecule of vitamin A1. Thus, the side chain contains 10 carbon atoms excluding the CH2OH group and has two CCH3 groups and the system of conjugated double bonds. Taking into account these facts, we can assume that there are two isoprene units in the side chain and the nature of the side chain is as follows. So this is one unit, this is another unit, one, two, three, and this primary alcohol. So one isoprene unit contain one, two, three, four, five carbon atoms. This is one isoprene unit. This is another isoprene unit and one primary alcohol. So 5 plus 5 and one carbon, that is 11 carbons are there in the side chain. Taking into consideration the above analytical evidences, the following structures may be assigned to vitamin A1. So this structure or this ring has been obtained by beta ionone to geronic acid transformation. We get the clue of this ring that it contains six, this six carbons, seven, eight, and nine. So nine carbon atoms are there in this unit, and this side chain contain 11 carbon atoms. Out of 11, one is in the form of primary alcohol and two are isoprene units, CH double bond CH, C CH3 double bond CH. This is one isoprene unit, and then similar another CH double bond CH, CCH3 double bond CH. So this one is another isoprene. This beta ion ring, one isoprene unit, two isoprene unit, and one primary alcohol. So the overall structure becomes like this. When heated, the 9 point is when this A1 is heated with an ethanolic solution of hydrogen chloride, that is HCl. Vitamin A1, that is this one structure, is converted into second. This structure, when heated in presence of HCl, gives this second structure, which on dehydrogenation with selenium, dehydrogenation, that means aromatization or oxidation, forms 1,6-dimethyl naphthalene. And Hell-Brown in 1932 explained this reaction assuming the structure of vitamin A1 as 1. It also supports the structure of vitamin A1. Perhydrovitamin A1 has been synthesized by Carrer 1903, starting with beta ionone. This was found to be identical with the one obtained by catalytic reduction of vitamin A1. That means from vitamin A1 we get perhydrovitamin A1, fully reduced vitamin A1, and that compound which is synthesized from beta ionone has been also found to be identical with the compound obtained by vitamin A1. So these are the analytical evidences. After all these analytical evidences, we can confirm the structure with synthetic evidences. Assuming the structure of vitamin A1, if we are able to synthesize in laboratory, then the structure is confirmed. So the structure of vitamin A1 has been confirmed by several synthesis of synthetic methods, and this Isler's synthesis is for our syllabus. This is the commercial method for getting vitamin A1. So it has Isler's synthesis of vitamin A1. Isler in 1947 synthesized vitamin A1, but this procedure has two steps, and here the synthesis starts with beta ionone. This beta ionone reacts with chloroacetic acid in presence of sodium ethoxide and ammonia. It gives intermediate, and this intermediate is addition product of beta ionone and chloroacetic acid. Here only this carbon and this carbon bond formation takes place, and we get here OH, and this OH is transferred here. So this is addition product or intermediate. This intermediate further remove this HCl, and we get same molecule with epoxide ring, and this is epoxide ester. Only changes in this part. So this epoxide ester, upon hydrolysis, ester converts into acid, and upon decarboxylation, this CO2 is removed, and we get epoxide molecule. This epoxide ester upon hydrolysis and decarboxylation gives epoxide. Opening of the epoxide ring. This three-membered ring is epoxide ring, and opening of this epoxide ring and shifting of H. This one H is shifted. So this double bond is shifted here. This ring is opened, and one hydrogen is shifted on this carbon. So opening of the epoxide ring and shifting of hydrogen takes place, and we get this A compound, that is aldehyde. Then in second step, preparation of Grignard reagent from acetylene and methyl vinyl ketone. Acetylene and methyl vinyl ketone reacts in presence of sodium in liquid ammonia to give addition product. Here the this carbon and this carbon forms bond, and we get addition product. This addition product further upon reaction with sulfuric acid rearrangement, that is allylic rearrangement, takes place, and we get this primary alcohol. This secondary, or we can, no, not secondary, this is tertiary alcohol converts to primary alcohol. This primary alcohol further reacts with two molecules of ethyl magnesium bromide, and we get this B compound. This preparation of this is also Grignard reagent, and we have prepared Grignard reagent in step 2, and in step 1 we have got A as aldehyde. So in the third step we are going to see synthesize vitamin A1 from A and B. So this A obtained in first step and B Grignard reagent obtained in second step. So this aldehyde and Grignard reagent reacts with each other via Grignard synthesis, and we get the this carbon carbon bond forming reaction. And further, this compound which is formed by reaction with A and B, this contain carbon carbon triple bond. This carbon carbon triple bond is converted into carbon carbon double bond by H2PdBSO4, that is hydrogen palladium barium sulfate catalyst. And only the change is conversion of this triple bond into double. Then further, this compound is subjected to acetylation reaction. That is, it reacts with acetic anhydride, and this primary alcohol is converted into CH2O COCH3. This COCH3 is known as AC, or it is abbreviated as acetyl, and this O, so OAC. Here, after acetylation, we get this compound, and only change is this primary alcohol converts into CH2OAC. And this acetylated molecule, after rearrangement, what happened? This bond, double bond shift to this carbon, and this OH have been shifted to this carbon. And this intramolecular rearrangement gives us this rearranged molecule, and this rearranged molecule further, upon dehydration by POCl3, that is phosphorus oxychloride, in presence of pyridine, gives this dehydrated molecule. OH from this carbon and hydrogen from this carbon have been removed, and minus H2O. So dehydrated molecule is obtained. This dehydrated molecule is further subjected to alkaline hydrolysis, that is basic hydrolysis, and we deprotect this primary alcohol which has been protected by acetyl group. Deprotection takes place via alkaline hydrolysis, and we obtained the primary alcohol functionality. And this is the structure of vitamin A1. Thank you.